Where? What? People stop coming to class? What is this? Huh?
So now you remember all the wrong things.
No, you're right. You're right. It does break off to those two.
So my kid actually blew out my driveway and sidewalk. Yeah, I couldn't believe it. I know. You got more faith in him than I do. Yeah. What's that?
How many people came on Tuesday?
4.
Y'all too, and her? And Kyle.
Right. I can't say anything, and I just, just use your best judgment. Okay, we got a lot of sick people here. What is this?
I didn't think the roads were going to be bad.
Oh, wow. Guess what?
The scariest part about this gateway, I don't like going down the hill to the parking lot.
Did you know there's another way?
I always think that
Did you go the other way?
Yeah.
Did you know that I got stuck? Yeah.
You got stuck on the way?
Yeah, I'll get it.
I've been approved the membership in the American Physiologic Society.
Ooh.
I just got the email today.
Congratulations.
Oh, wow. You know what? It makes this official now. I mean, I already knew it, but this makes it official. I got a membership number, everything. So now I am better than all of you. That's right. As soon as I got my official number and everything, I'm probably going to get a little pin in the mail, too. Yeah. Sometimes that's, it should be implied, but a lot of times people don't get it. That's so stupid. Okay, here we go. We're going through this. That he was better than them? He was serious? And the teacher said, I'm better than you? You know what? People are weird. All right, here we go. Okay, so come on now. Got to work hard. Okay, for big extra credit on the final, I'm going to have my sputum cultured, and if you can guess the causative organism, you'll get extra credit. Yeah. And if you can determine the antibiotic that they will place me on. Okay. It's always broad spectrum. Always. Okay. Look, I'm recording now for 4 darn minutes. All right, we're going over the kidney. Did I start the kidney at all? I didn't? Not at all. Okay, here we go. I thought I did. Didn't I go over the functions of the kidney? Huh?
Oh, yeah, it was an intestine. Large intestine was the last thing.
Oh, okay. So we're done. We're through the digestive. Okay, we're starting the kidney. Hey, we didn't go over lactose intolerance? Okay, we'll do that. Here we go. We're going over lactose intolerance. If anyone is lactose intolerant and they want extra credit, they can eat some ice cream or drink some milk and then come to class. Yeah. Okay, here we go. All right, ready? Ready? Benta, you ready? Okay. Corey, you ready? Brad? Okay. Toya? Ready. Okay. Rest of you guys are ready. I know that. Here we go. Where does the vast majority of digestion and absorption of nutrients occur in the GI tract? My name is, it's right there if you read it. Good. You guys can read. Here we go. We're on a roll today. So, watch. And I explained to you that in the lining of the small intestines, there are specific enzymes that are embedded in the lining of the small intestine, right? Each one will break down a specific nutrient. In people who are lactose intolerant, they lack the enzyme lactase. A lot of lacking going on. Lactase. So they cannot digest the sugar lactose, which is found in dairy products. Are you with me? So lactose, the sugar lactose, goes through the entire small intestines undigested, and then it ends up in the large intestines. Does any digestion occur in the large intestines?
No.
Say yes. Yes. Because in the large intestines, and you better know the divisions, right? You have bacteria, friendly bacteria. They're the friendliest bacteria you know. 700 different species of bacteria colonize your colon. Oh, yeah. They're called normal flora or normal biota. You've learned that in microbiology. Ain't that right?
Yeah.
So you now have that sugar lactose, and you have these bacteria. And the bacteria will begin to digest, break down that sugar lactose. And then the sugar lactose, when it's digested by bacteria in the large intestines, produces carbon dioxide and methane. Those are gas. That's why you get gassy and bloated if you're lactose intolerant. Do you see that? All right. Bam. This, when ignited, produces a blue flame, too. Anybody here ever light their farts on fire? No? If you do that and put a video on it on YouTube, I'll give you extra credit. But you have to prove it that it's you and that you're actually farting and lighting it on fire. Anyone want to do that? No? Okay, good. Yes. The bloating is a result of the gas, and then you're just ripping them. Yeah. Okay. I went through the parts of the large intestines, the function. I know I did, right? Okay. All right. We're moving on. We're going to move on. We got to move on. Okay, remember, starting next Saturday, I will be here from 9 till noon. You got me? And guys, look, anytime that you can spare that this lab is open, come and study. You got me? Kyle? All right. So here we go. We're going over the kidneys, the urinary system. And here's the thing. The urinary system is kind of like the stepchild of the body. Nobody ever talks about it unless something goes wrong with it. You know what I mean? The urinary system and the kidneys are badasses. They really are. They're huge players. And a good understanding of how this works is really important. All right, so watch. You got two kidneys. You only need one. So there's a redundancy in it. And the kidneys, here we go. One of the functions of the kidney is to filter blood. And it filters that blood and removes metabolic waste. Now, this is important. And again, every time I go over something, I'm going to explain to you why you need to know it from a clinical standpoint. All right, do you know anybody who is on dialysis, who's in kidney failure? Do you know anybody? You do? Okay. Can they have as much protein as they want? They're on a protein-restricted diet, aren't they? Do you know why? You were lying? I didn't hear you, so it's really not a lie. That's not bad. Watch. You're going to learn, and you don't even know this, but you know this. But you don't know you know it, you know? Watch. If you break down glucose completely with oxygen, please get this right, what's left over? My name is, what's left over? Oh, I had a girl. CO2, what else? Heat, water, ATP. You got me? What system controls carbon dioxide? The respiratory system. Watch. If you take fat and you completely break it down, what do you get, Cora? Good, very good. Very good. You did good. Okay, now watch. And we learned this when we were talking in the first couple of days of class. I'll never forget it. It was a Tuesday. Yeah? If you get this right, I'll be really proud of you. And I know that was meaningless to you, but I will be anyways. What's this? What is that? What is that? That's an amino acid, right? But what's this little thing here called? Toya, what is it? You better tell me. This is called the amino group. You got me? You would have never guessed that? Okay. Have you ever gone to Summerfest? The amino group opened up for Menudo at Summerfest. Menudo. It's like a stupid name. Menudo. Sounds like something you eat. Hey, get some menudo. Is menudo something you eat? Oh, see? There you have it. You know that they have a band that plays Summerfest called the Fatty Acids? Look it up. Look it up. Guaranteed. Look it up. Dare you. Right? Look up Fatty Acids Summerfest. I think it was 2 or 3 years ago they played. All right? Here we go. Now, I'm sick, so I'm going to try and do a really good job. I'm sick physically, just so you know. The mental part, well, you know. It's always been there. Okay, now get this. When you eat protein, those amino acids go to the liver. Please get this. And the amino group gets hacked off. And it gets converted to what? Cheryl, what's this? What's that? No. This only has 2 hydrogens. This got 3. You said it before. Ammonia. Is ammonia good for you?
No.
Should you have an ammonia in captains? No. Ammonia is toxic. It will kill you. So you better watch this. The ammonia in the liver gets converted to a less toxic substance called urea. What does urea sound like?
Diarrhea.
All right? It sounds like urine. Can you breathe out urea? So what's the only way that you can get rid of urea? Is to pee it out. And what filters your blood? Your kidneys. Are you following this? Yeah. So one of the metabolic wastes that the kidney has to get rid of, look at that. This thing's sick too. Samana. Write this down. One of the metabolic wastes that the kidneys have to filter out of the blood is urea. Who's following that? That's good. So here we go. Now look. And you're going to get this. Okay. So where's urea made? In your liver, right? And it's a byproduct of protein metabolism. But it's gotten rid of in the kidney. And these are two metabolic wastes that the kidney has to get rid of. Ammonia and urea. Most of the ammonia is converted to urea, but there's a small amount of ammonia. What does urea and ammonia have in common? What compound? And I'm circling it. It's nitrogen. So if you've ever had your labs drawn, there's a test to look at kidney function, and it's called blood urea nitrogen, or BUN. Have you heard of that? Right? You've seen it on a lab, yeah? What's that an indicator of? Kidney function. Say yes. Now watch. If your kidneys are going bad, do you want to make more urea and ammonia? What makes urea and ammonia? So people who are in kidney failure are on a low protein diet. Do you have any idea how good that information is right there? It's rock solid. Solid as a kidney stone. Solid as a rock. Who's following this? Okay. Watch. I kind of lied to you a little bit, but it was for your own good. Just like you lied to your kids about Santa Claus. So don't give me none of that. What's that? That's a muscle. See, like this. Watch. Remember when I told you muscle stores ATP, a little bit of ATP? Remember that? I kind of lied to you. Muscle stores ATP in this form. You better write this down. Creatine phosphate. Creatine phosphate. Where do you find creatine phosphate? In your muscle. Better get this. When creatine is metabolized, it's metabolized to the waste product, creatinine. Can you breathe out creatinine? No. So it has to be filtered out of your blood. And what filters creatinine out of your blood? Your kidneys. So the two blood tests that look at kidney function are, number one, blood urea nitrogen, and number two, creatinine. Now watch, and you're going to think, and now you're going to say, oh, Timmy, that makes sense. I'm going to say, yeah, I know it does. Ready? If you eat more protein during the day, what's going to happen to your blood urea nitrogen? It's going to go up, right? The amount of waste products are going to go up. Have you ever woken up one morning and you were really skinny, and then you woke up the next day and you were just like all muscle? Did that ever happen to you? So does your muscle mass change much from day to day? Does it? No. So the amount of creatinine that you produce doesn't change from day to day. So what's the best indicator of kidney function? Blood urea nitrogen, which can change based on your diet, or creatinine, which doesn't change because your muscle mass doesn't change? What's the best indicator? Good. That's why I put this slide up too, so you would see it. You got me? So creatinine is the gold standard for assessing kidney function. Don't you like that one? The gold standard. Like urine's yellowish gold, and that's, you know, when you got to explain it. That's one of the few jokes that I actually don't go, no? Use it every year. I get the same response too, nothing. Okay, watch. How many people had to get drug tested to get a job? Okay. They're not using pee anymore, they're using hair, right? So if you spend your cuckoo for Dopo Puffs, that stuff stays in your hair for about a year. So if you want to get a job in healthcare, you better stay away from, the chronic, the tree, right? Ganja. Huh? On the weekends, too, just so you know. But anyways, this is maybe 15, 20 years ago. I get this email from this guy who dehydrates his urine, I'm not even kidding, and sells it over the internet so people can pass their drug test. You've heard of this? How'd you hear of it there, Kyle? Oh, doing a search on the internet. Anyways, watch. I don't know how he got my email, but he sent me this email, and he was looking for a name for his product, right? So it's this contraption where you put the dehydrated urine, you mix it with water, and then it actually looks like you're peeing, right? So he was looking for a name, so I sent him back urine ploid. Don't you think that's a good one? He went with the Whizzinator. Have you heard of it, the Whizzinator? Yeah. Don't you think that's a better name, urine ploid? Yeah, son of a... He didn't. I could have made some... No, probably not. Anyways, okay. So, watch. What are the waste products the kidneys got to get rid of? Ammonia, blood urea nitrogen, and creatinine. And again, what's the best indicator of kidney function? Creatinine. So when your creatinine levels start going up, that means your kidney function is failing. Say yes. Okay. So that's the metabolic waste. The other thing, you better write this down, better not pout. The other thing that the kidney does is it maintains long-term pH. The kidneys can correct any pH disturbance if you live long enough. You got me? That's why if you work like in an ICU and somebody's really doing bad, like their heart's not doing so good, right? They will put them on temporary dialysis to correct their pH and to remove the metabolic waste, because if their kidneys start shutting down, it's over for them. So the kidneys do a ton of stuff to maintain life. The other thing they do is they maintain long-term blood pressure. And they maintain long-term blood pressure from a very simple mechanism called pressure diuresis, which we're familiar with, aren't we? Aren't we? Right? So if you drink fluid, your blood volume goes up, venous return, stretch, can't even do it anymore, force contraction, blood pressure, pee more. Yeah. And then we talked about filtering metabolic waste, right? Make sure that you include what those metabolic waste are. By the way, what do you use ammonia for?
Cleaning.
Right. So if your man pees on the toilet seat, he's actually helping you clean.
Yeah, nice try.
Here, honey, let me clean the shower for you. That's, what? Oh, whatever. You know, you guys are what? And this seat thing, man, like that's a big deal. Look. Then look and put the seat down. Or take your chances that you're going to be sitting in some urine. Right? Those are your options. Okay. Ready? Yeah? Long-term blood pressure, metabolic waste, maintaining pH. Here's the other one. The kidneys are very sensitive to drops in oxygen saturation. As a matter of fact, the kidneys are so metabolically active, they demand a lot of blood flow just to keep the kidneys alive, and that means they demand a lot of oxygen. So short periods of lack of oxygen to the kidneys can cause acute kidney failure. So the kidney monitors oxygen saturation of red blood cells, and if there is a decrease in the oxygen saturation of red blood cells, it releases a hormone called erythropoietin. You may know it as EPO. And that erythropoietin then goes to the bone marrow and stimulates the bone marrow to make more red blood cells. So, Lance Armstrong? Yeah? He was taking synthetic erythropoietin. So it would stimulate his bone marrow to make more red blood cells. And because it's a hormone that stimulates cell division, they believe that steroids that he was taking were the result of that's what causes cancer. Right? So don't do that. Reading the textbook reduces your risk for cancer. Are you writing that down, Toya? Okay, good. The other thing that the kidney does, write this down, is it activates vitamin D. Vitamin D begins its synthesis in the skin. It then gets further processed in the liver, but it actually gets activated by the kidney. And vitamin D is required to absorb calcium from the gut. So that's why when people take calcium supplements, they also take vitamin D along with it. And in order to get to enough vitamin D, you have to have at least 1 hour of direct sunlight each year. So people who live in the northern states, right, where the days are shorter, a lot of them now are being checked for vitamin D deficiency and being supplemented for it. And that vitamin D it's like the new vitamin C. It cures the mange and everything. Vitamin D is required to absorb calcium from the gut. Without vitamin D, you can't absorb calcium. So you get a condition called rickets. Do you want rickets? No. You want to go to Gateway. So on your to-do list, avoid getting rickets, and go to gateway. Are you with me? Okay. The other thing that the kidney does is it maintains electrolyte balance. Now, you eat salt like it's going out of style. That popcorn's got 9 pounds of salt in it, right? Now watch. If your kidneys are working properly, you can eat as much salt as you want because the kidneys will take care of it and pee out that excess sodium and chloride. So anytime your kidneys run, please write this down. And I'm not even kidding you. If you say it on the final, I will give you 2% extra credit. And I'm never going to, right, you should see now. You guys, right, you guys are like, I'm not even kidding. You're like a panther waiting to attack. When an organ fails, all the functions of that organ fail. If you say that when you take your final, I will give you 2% extra credit. And for some of you, that could be a difference maker between a D and a C. You got me? So, if you look, watch. If your kidneys begin to fail, what are you going to have problems with? Will you be able to adequately filter your metabolic? So what will happen to your blood urea, nitrogen, and creatinine? It will go up. What will happen to your ability to monitor oxygen saturation and then release of erythropoietin? It drops. So if you can't replace new red blood cells because your kidneys are failing, you become anemic. Will they be able to activate vitamin D and absorb calcium from the gut? No. So they develop rickets or osteoporosis. And will they be able to maintain their electrolyte balance? No. So they will have pH and electrolyte imbalances. And in a person who's on dialysis, can they drink as much water as they want? No. And the reason they can't do that is because you don't get that pressure diuresis if your kidneys aren't working. So they will retain fluid. Say yes. Do you see this? This is what I try to tell you, that if you know the functions of an organ, you'll know what will happen if the organ don't function. Are you writing that down, Cora? Okay, Cora's writing it down. Okay, those are the functions of the kidney. All right. Now, I want to show you something. And again, I'm not doing this to be a jerk. I'm doing this to help you. I know the sticking points when people get into the clinical. I know them. And one of the sticking points is fluid and electrolyte balance. And one of the reasons that students struggle is they don't understand how the kidney works. I'm going to explain that to you. Yeah, and then we're going to hit a lot harder when we get into advanced. You ready? But you're going to have a general idea. All right, here we go. Okay, now watch. You got two kidneys. The kidneys are what are referred to as retroperitoneal. If you've ever seen a kidney up close, and I'll show you one, right? What they do is they tend to wear those felt hats with the feather in it. See, they're retro. Yeah. Yep. And they have a cane. And they will do their daily exercise. Do you know what he's doing? Do you know what he's doing? Do you know what he's doing? He's keeping his pimp hand strong. I have a fever. He had the felt. That's so stupid. I hate me too, just so you know. Okay, so please get this one. Retroperitoneal. Write this down. Not even playing. Write it down. Put a star next to it. All of your guts, all of them, all of your guts are wrapped, stored in a big, hefty bag. All of your guts, right? There's a big membrane that encases all of your guts. Do you know what that membrane's called? Well, I don't know either. I'll tell you, because I like you guys, as far as you know. It's called the peritoneal membrane. So the kidneys are actually outside the peritoneal membrane. And the peritoneal membrane, watch it, is an incredible, selectively permeable membrane. And because the kidneys are not within that big hefty bag, they're outside, the peritoneal membrane makes a beautiful dialyzing membrane. That's why people, instead of having hemodialysis, can undergo peritoneal dialysis. Have you ever heard of peritoneal dialysis? Well, you did today. So, because they're not encased in that, the kidneys are outside of that, that peritoneal membrane can be used as a dialyzing membrane. That way people don't have to sit at a place for 5-6 hours and get hemodialysis. So peritoneal dialysis is usually reserved for people whose kidney function is bad, but they don't have a lot of other problems. They're relatively, like young people, right, where they need to do that. Because you can do that while you're on the go. You can put the fluid, dialyzing fluid in your belly, so you have like little tubes that run into your belly, and then it will cause the stuff from the blood, because the kidneys are outside of the peritoneal membrane, to be brought through that dialyzing membrane, and then you drain the fluid out. That's how you filter your blood. That's peritoneal dialysis. You know what I'm talking about, right? There you go. All right. So that's how it works. So look, what's this guy right here? This gland that sits on top of the kidney. Well, you can just read it. The adrenal gland. And one more time, what hormones released from the adrenal medulla? Right, but what do we call it? Right, and how you know where the adrenal gland is by the word epinephrine. Epi means outside, nephr, kidney, ion, hormone, epinephrine. You like that? Well, good. You didn't like the creatinine being the gold standard, though, did you? Bunch of haters. Okay, here we go. So watch. 2 kidneys. Write this down. 20% of your blood at rest is filtered by both of your kidneys each minute. And write this down. It is the arterial blood that is filtered. Arterial blood is filtered. Why is arterial blood filtered? Because arterial blood, Maria, is, and what? Say that real loud, I can't hear you. No, what else? It's under pressure. That's good. It's under pressure. Is there any pressure in the veins? No. No. That's very good. So it is the arterial blood that is filtered by the kidney. And the big vessel that carries that arterial blood to the kidneys to get filtered is called the renal artery. So you have 2 renal arteries that come off the aorta, and they send that arterial blood to the kidney to get filtered. Bless you. Say yes. To get filtered. All right, now watch. Let's do this. What's in blood? Good. Water. What else? All right, and yeah, see, we learned a lot more. Remember the first day stuff? Now look at all the stuff we're learning. There's still stuff, right? So there's sodium, potassium, okay, the electrolyte. What else? Come on. What else? We got water and that's it. Protein. You got protein in there. What else you got? I heard it. Red blood cells, good. I like that one too. We'll say glucose because we're in science class. Yeah? Come on, what else? Do you got vitamins in there? Yeah, of course. Yeah, I need some. Vitamix. Vitamins, what else? I've got a lot of them floating in my blood now. I better. No, that was last night. I better tell you. White blood cells, yeah, right? And then you have waste products you got to get rid of. Urea, watch, 673. The new math.
Not a math class.
The new math. Urea, creatinine. Tell me you got that? And ammonia, right? So these are some of the things that are in the blood. Red blood cells, white blood cells, protein. There's a big protein in the blood called albumin, right? Albumin's a giant protein. Red blood cells. Are red blood cells big? Yeah. White blood cells big? Say yeah. Yeah, good. Electrolytes, water, glucose, vitamins, those guys are little. Say yeah. Okay, so here we go. Now I'm just going to give you an introduction, and then I'm going to get serious about this. So as that arterial blood from the renal artery goes into the kidney, please get this. The kidney's job is to filter the plasma of the blood. The formed elements of the blood, the large formed elements, red blood cells, white blood cells, and albumin. Should you ever be peeing blood? Should you be peeing pus? No, right, that's exactly how you should say it. No, right? I'd rather read the textbook than pee pus. How about you? Should you pee egg white? Albumin? Should you? No. So those remain in the blood. So what the kidney actually does is filters the plasma of the blood. So the things that never should be in urine, and this is on the final, are red blood cells, white blood cells, albumin. Why? Because they're too big to get filtered out of the blood. Too big. Red blood cells, white blood cells, and albumin, too big to get filtered out of the blood. All right? And then I'll just remind you, glucose is on that list too, right? And I'll explain why when we get in a little deeper. Okay? Watch. So the kidney filters the plasma, and what's left over after you filter the plasma is urine. So where do you make the urine? You make the urine in the kidney. And then, watch it, there are two hollow muscular tubes that connect the kidney to a big hollow muscular organ. The hollow muscular tubes that connect the kidney to the bladder are called ureters. They're hollow muscular tubes. What's the esophagus? A hollow muscular tube. How does food move from your back of your throat to your stomach? How does it do that? What's that called? Peristalsis, right? So when you make urine in your kidney, that urine moves from the kidney into the bladder by peristalsis. Say yes. Who's with me? And each kidney has one ureter that drains the urine from the kidney and empties it into the bladder. And just like the rectum damn near killed him, where's Kenny? There's Kenny. Don't that look like Kenny?
Oh my God.
Watch, you got the bladder, and you have an internal sphincter that's under autonomic control, and an external sphincter that's under conscious control. So when your bladder starts filling up with urine, the pressure inside that bladder is increasing. And when that pressure hits a critical value, it's going to cause the internal sphincter to relax. But you don't want to be piddling in your pants, do you? So you tighten up that external sphincter and wait till it's appropriate for you to go. Then you relax that, and then you pee into the toilet or wherever. Tell me you got that. Did I tell you that in 1985, me and my buddy, we went to a Brewers game, and we were tailgating, and we seen these two girls walking by going to the game. And I said, hey, girls, you want to see my buddy pee over a van? My buddy peed over a van. That's pretty good, isn't it? I told him, you got to put that on your on your resume. You don't think that's impressive? I can tell by the lack of eye contact that you want nothing to do with that. Okay, so watch. As that pressure builds up, the internal sphincter autonomic control is going to relax. You tighten up the external, wait till it's appropriate to go, and then you pee. As you get older, that external sphincter becomes weakened. Women who are pregnant and you put pressure on your bladder, that weakens that external sphincter. So they get a condition called stress incontinence. They sneeze or they fart and they will piddle their pants. You ever get that too? And I know you guys do it, right? You're like, I can't wait to get out of this class. So class is over, right? And you're like, I don't want to waste any time. So I'm going to wait until I get home to go to the bathroom. And then you're driving, right? I'm like, I'm okay. Right? Then you hit a bump like, ooh, hang on. Then you get about a block away from your house, and it hits you, right? It's like, oh, my God, I ain't going to make it, right? Then you're like hoping that you can find the keys. You're fumbling with it. You know, as a guy, you can go anywhere. You know, women, they have a little harder time. That sucks. Like being a woman, like you're on a boat or something like that, that really sucks. You know? One time when me and my ex-wife were getting along, that was a long time ago, we took a drive out to Denver. Just got in the car and drove. And they had these, we're on this highway where all it was sunflower seeds. And she's like, I got to go to the bathroom. I'm like, okay. So she gets out, right? She gets behind the car, and then she's squatting. And then I see a car coming. So, of course, I pull up. Oh, she was so mad. Oh, God. I believe, like, women, they get mad. Their fingernails grow, like, right then and there. She was so mad. Anyways, tell me you followed that. All right? So, watch. The ureters do not connect at the top of the bladder. They actually go underneath the bladder. So the urine actually kind of bubbles up. You got me? All right. Can I show you something? This is going to, look. What I'm going to do for you is I'm going to cut the kidney in half for you. I got a picture of the kidney being cut in half and a couple of clinical things that are really, really important. I don't like this diagram. It just bothers me. And I'm basically too lazy to change it. All right, so this is a cross-section of the kidney. So let me give you a couple of anatomical landmarks. And these are true of almost all organs of the body. Watch. A part of an organ where large structures enter it or exit it, that's referred to as the hilum of the organ. So the hilum of the kidney is right here. What do you have entering and exiting? You have the renal artery, the renal vein, and then you have the ureter, which drains the urine that's produced by the kidney. Now watch. The hilum. And that goes for any organ of the body. Now look, I'm going to move kind of this way as I explain the structures. Now here, this little golden area here, this is called the calyx of the kidney. Calyx is Greek for the word cup. So cup of soup, cup of urine. This is where the urine kind of waits to leave the kidney and go into the bladder. So I refer to it as the urine commons area. You know, the urine comes there and talks about their day. How was your day? Well, I'm a little pissed off right now. Get it? Okay. All right, watch. Then the kidney is divided into two large sections. You have the medulla of the kidney, and the medulla of the kidney is broken down into what are called renal pyramids. Are you with me? See these areas here? They look like little pyramids. Not to me they don't, but that's what the book calls them. You got me? Those are the renal pyramids. And then you have the outer portion of the kidney, and that is called the cortex of the kidney. As a matter of fact, the outer portion of any organ is called the cortex, and the inner portion is the medulla. Are you following this so far? Now, if you look, and again, this is important, what happens to the renal artery when it starts moving deeper and deeper into the kidney? What happens to the renal artery? It gets smaller. So as the renal artery carries the blood that's going to be filtered by the kidney, it starts branching off and getting smaller and smaller, right? Until it ends at an artery that begins the functional unit of the kidney. And the functional unit of the kidney, this is where that plasma, that blood is filtered, that plasma is filtered. It's called the nephron. The nephron of the kidney is where the plasma of the blood is filtered. And on average, you have 1 to 1.5 million of these nephrons in each kidney. And when about 80% of those nephrons in both kidneys are shot, you have to undergo dialysis because it cannot adequately filter your blood anymore. Are you with me? All right. So what I'm going to do now is I'm going to explain to you the basic structure of a nephron. And guys, this is really important. Really important. 80% of the nephrons of both kidneys, if they're destroyed, you have to undergo dialysis, hemoperitoneal. All right, so watch. I'm now going to explain to you the functional unit of the kidney. And the functional unit of the kidney is the nephron. This, ladies and gentlemen, is a nephron. And it looks complicated. That's because it is. I'm just kidding. I'm going to break it down for you, just like I do everything else. Am I right? All right. Here we go. Okay, watch. Get this idea. Urine, what is ultimately urine, what you can call your urine, right? You can take, ownership of your urine, is accomplished or produced by the nephron, and it's done so in 3 ways. Number 1, urine is formed when you filter the plasma. Now, filtering of the plasma is a mechanical process for the most part, right? How much plasma is filtered by the nephron is really determined by the person's blood pressure. So if their blood pressure is very low, the amount of plasma that's filtered by the nephron is going to be reduced. That's why people who have low blood pressure or are dehydrated have low urine output. Are you following this? The second thing is that you can filter the plasma, but some things just can't adequately be filtered. But they're waste products, and you've got to get rid of them. And so you have to actively secrete stuff into the urine. It can't be filtered, so you have to actually put it into the urine. And then finally, what was filtered by the nephron, that will get reabsorbed back into the blood, and I'll explain that. Now watch. When you ate some Fruity Pebbles for breakfast today, yeah? When your digestive system digested it and brought it into the blood, and then it went to the liver and then got dumped into the central circulation, it got absorbed into the blood. If it's in the blood and then gets filtered out of the blood and then brought back into the blood, that's called reabsorption. Say yes. Okay, now I'm going to be very, very generic here, and then I'll get a little more specific. What blood is filtered by the nephron? That's right, because it's under pressure, right? And what happens to the size of the arteries as you get deeper and deeper into the kidney? They get smaller until those arteries terminate at the artery that begins the nephron. And that little artery right here that is carrying that arterial blood under pressure, that's called the afferent. What does afferent mean? Towards. Afferent, towards. That afferent artery carries blood towards this ball of capillaries. This ball of capillaries is called the glomerulus. The glomerulus, how I like to explain it, is like a spaghetti strainer. When you make spaghetti, what do? You boil water, you throw spaghetti in there, and then you take the strainer and you dump the water and spaghetti into the strainer, and the water and the salt and whatever you put in there gets strained out, but the spaghetti stays in there. See, yeah. Then you put it on a plate and you eat the spaghetti. Yeah. How many people like spaghetti? The glomerulus is a strainer. Okay? So by definition, a glomerulus is a big ball of capillaries. And how thick are capillaries? Okay? So it looks like this. Now watch. Now get this. You're going to get it. This picture right here, this little area right here, I'm going to blow up and simplify. Boom. That's that area here. So if you look, now, come on, guys. I need you to totally be with this. Here we go. So look. This guy right here, this is the afferent arteriole. You got me? Here's the ball of capillaries. So as that blood comes into the glomerulus under pressure, it is going to force water and small stuff out of the glomerulus and into this little catching container. This little catching container that surrounds the glomerulus catches, excuse me, catches what's filtered by the glomerulus. This is called the glomerular capsule or Bowman's capsule. So watch. Think of the glomerulus as like the spaghetti strainer and the glomerular capsule as your sink. So when you pour the spaghetti and the water into the strainer that you have in the sink, the spaghetti strainer, glomerulus, catches the big stuff but lets the little stuff go down the drain. Are you with me? So what's big in your blood? Right, red blood cells. In this case, they're yellow. What else? White blood cells. I'm going to make them white for you. White blood cells and, yeah, that big freaking protein, albumin. They're so big, they're the spaghetti. You don't want the spaghetti going down the drain. So they are caught by the spaghetti strainer. Please get this. And those things leave the glomerulus through the efferent arteriole. Are you with me, guys? Who's following to me? The afferent artery here. Afferent, same, you're right. That's where the blood comes into the glomerulus to get filtered. Then the plasma gets filtered, and what's not filtered leaves the glomerulus through the efferent arteriole. Who's with me? Guys? Now watch. What was filtered by the glomerulus gets caught by Bowman's capsule. The stuff that is filtered is called filtrate. And we know what's in it, right? We know what's in it. We know that there's water. There's electrolytes. Ain't that right? Right? There's amino acids and small proteins or vitamins. Right? There's glucose. There's fatty acids. Yeah. That's in the filtrate. You got me? And that's in Bowman's capsule or glomerular capsule. So now get this. Now watch. So you got the stuff that was filtered by the glomerulus, and it's going to enter what I like to refer to as the yellow brick road. Follow it. Follow the yellow brick road. These are what are called the collecting tubules. The collecting tubules obviously collect what was filtered by the glomerulus, and then it travels the yellow brick road. Now, how I explain this, and I hope you get this, is the nephron filters all of the plasma. You got me? And then as it travels the yellow brick road, the stuff that it needs is reabsorbed back into the blood. So watch. If you're going to clean a closet, how do you clean a closet? How do you do it? You take everything out. So the glomerulus filters all of the plasma. So you take everything out of your closet. Then you decide what you want to put back in. So you've filtered all of the plasma. And then as that filtered plasma travels through the yellow brick road, the nephron decides what it's going to bring back into the blood. That's the process of reabsorbing or reabsorption. Please get this. Yes? And they got it going on here. They figured it out perfectly. Now watch. The efferent arteriole leaves the glomerulus, and the efferent arteriole then forms a network of capillaries that surround these collecting tubules. These network of capillaries that surround the collecting tubules are called, oddly enough, peritubular capillaries. Are you with me? So watch. Here's a capillary, right? Here's a capillary network, and there's stuff in the yellow brick road. Let's say this guy right here. We don't want to pee that guy out, whatever it is. It then gets brought back into the blood. So this network of capillaries will then be able to reabsorb stuff back into the blood so it's not peed into your toilet. Right, so, I mean, look, it's like, here, watch. So here's the collecting tubules. And here is the peritubular capillaries. So there's stuff in that got filtered in the collecting tubules. You with me? That stuff that got filtered and ended up in the collecting tubules, as it moves through the collecting tubules, it will get reabsorbed back into the blood based on the needs of the body.
So is it diffuses to it?
Well, right. Watch. In this class, all you need to know is that stuff that ended up in the collecting tubules, if the body needs it, it brings it back into the blood. Yeah, well, wait. Sim porters, co-transporters, right? I don't even want to talk about it, Willis, not right now. All you need to know is that the stuff that got filtered by the glomerulus and it ends up in the collecting tubules, as it travels the yellow brick road, there is a capillary that rides right next to the yellow brick road, and it will reabsorb that stuff back into the blood based on the needs of the body. Say yes. Now watch. You clean your closet, and You take out your textbooks. Wait a minute. I'll give you an example of something that you would actually use. Your skis, right? You're going to go skiing today. Are you going to take the skis and put them in your garage? So when you're done cleaning the closet, you can run back to the garage and get them and then put them in your closet. Where are you going to put the skis? When you're cleaning your closet, knowing that they're going to go back into the closet. Where would you put them? Right next to the closet. Say yes. So watch. The first part of the collecting tubules, and anytime you have a anatomical part that is closest to the origination of the big part, it's called proximal. Watch. Where's my arm attached? Good. Are you going to write that down? So watch. My arm's attached to my shoulder. So my elbow is proximal to my wrist. My elbow is closer to the point of origination of my arm, which is my shoulder. Tell me you got that. My wrist is distal to my elbow. It's farther away from the point of attachment than, tell me you got that. So when you got the glomerulus and that stuff got filtered into the collecting tubules, it will then move through this little twisted, convoluted tubule called the proximal convoluted tubule. And in the proximal convoluted tubule, you better write this down because I'm expecting it. 70% of the stuff that got filtered by the glomerulus gets reabsorbed back into the blood. That's the water, the electrolyte, everything, 70% of it. And it made sense, right? As soon as you filter it, you want to reabsorb it. And the first tube that filtrate enters is the proximal convoluted tubules, so the vast majority of it is going to get reabsorbed there. Tell me you got that. Now, watch. The cells that make up the proximal convoluted tubules are loaded with mitochondria. This is a metabolically active process. This requires a lot of energy. There is active transport of that stuff that's in the collecting tubules back into the blood. So the kidney requires a lot of energy. Who's with me? You're following this. Here, take a break. We got through that. Then I'm going to get through the Lupodon Henley. Okay? I wanted you to take a break so you're well rested.
Well,